Everyone. I hope you guys are doing well. I'll just share my screen in a second. Just tell me if you guys can see this. Can you guys see my screen? Laksha, can you update me?
Yes, I can see your screen. You can continue.
Yeah. Okay. So a quick introduction, guys. I am Anisha, and I am an associate software engineer at Red Hat since 1.5 years. I started open source contribution in like before 5 years, and ever since then I'm using Git. So today I'm gonna share some knowledge that I I obtained since last few years, and this is going to be very interactive session. So feel free to ask questions, and uh, Laksha will share the slide links with you in YouTube. So also feel free to go through the slides. I have added resources in there. Okay, so today's agenda, I didn't add all the technical Git stuff. So basically, what we have to do is we have to observe the demos carefully, and we will are going to experiment with Git CLI, and we will explore GitHub UI, and in this process only we'll learn Git and GitHub. So that's simple thing that we have to do today. So, what is Git? Git is a version control system. Okay. So, not only Git, there are many other platforms which can be used for the thing that GitHub does. There are a lot of and a lot more version control system. I have added a link here to if you want to go more through the version control system. So basically version control system are a category of software tools that help a software team manage, collaborate their source code over time. So when there are a lot of people, so it helps to collaborate and to share the code in a very efficient way. Okay. So let's talk about how usually we work with our file system. Okay. So when like a single person works on a file system, what we do, we create a file, we save it, we then we edit it and we save it again, right, in our local system, and we repeat the same procedure. So that's how we handle that file system. That's our version control system. But the thing is, in this thing you can't go back to a version, or go forward to another version. But just imagine making the same document in Google Doc or something. So in that you can create a file, you save it, you edit it, then you can see the edit history, and you can actually go back to that particular version, and you can resolve it and save it again and repeat. But now this same thing doesn't even like multiple people work on a Google Doc, that this thing doesn't happen, because nobody will know like who changed it, or the like when that person changed it. So you can't actually manage a lot of people on that kind of version control system. And the third kind is like to manage this kind of scenario. What we do manually is we create different file for different persons. Like person one creates a file, it saves it, edits it, then person two does the same thing, right? So this procedure is called manual version control system. Like for example, I created a text file with my name, and then I created another version. Then somebody else came, and he or she created other version, and this is called manual version control system. Now what GitHub does is GitHub automates this process. GitHub takes care of these timelines, and who did what. So like I said, sorry. So like I said, like when you work on a manual version control system, you can't really answer the questions of these, like when the file was modified, what was in the file which was changed, why is it modified, and who modified it, or like if the code broke, then who did it, which piece of code did it. So and most importantly, importantly, who is the person, how the person needs to achieve the same thing, because most of the time we reuse a particular chunk of code, and we need to know how that the same thing is implemented, and we can just fetch from other person, but that's not possible while doing manual version control. So GitHub is the answer of all these questions. GitHub is a free and open source system. So it handles everything from small to large project with speed and efficiency. It tells us when the user did any changes, why the user did any changes, who did the changes, and when, in which branch, and so on. I believe that you guys are already much familiar with these concepts. Um, so yeah, there is a resources such a handbook, which is very wonderful tutorial for people who are complete beginner and want to know why GitHub and what are the steps to uh, uh, use GitHub. Though we are going to cover it in this talk as well. So feel free to go through that. Meanwhile, I'd like to request Lakshya to share the slide link with all you. Okay. So next thing is why should we use GitHub? Because first thing that I would say is there are many more version control systems, but the UI of GitHub is much more user friendly than any other version control system. So that's why many people prefer to use GitHub, and the main GitHub provides is the security, the collaboration happens at any time, and the maintaining of the branches and branches for developers are very safe to propose any changes to production code. Then the users can collaborate as in their timeline, in their time zone, and they can work on the changes and discussion and progress at their own pace at while at meanwhile collaborating with other people. And business using Git can break down communication barriers, because it's very easy to communicate and get about an issue or any enhancement feature. And between the teams, it really focuses on teamwork. So that's why it's very easy to use Git while doing collaborative programming. Now, we'll go into the technical, practical approach. There are some common terminology in Git. First thing is organization. So, if a person starts an organization, that means that organization is an umbrella project that has multiple projects inside it. Like, for example, the student code, and the student code is an organization which has multiple projects inside it, right? So the place where student code and stores its projects is a repository. Not only student code, and what, like, when you create a space or directory in GitHub to uh, create a project, that directory is called a repository. Okay, it's the terminology. Then the people who create changes to the repositories are contributors. And then there are two things which are most important in GitHub is issues and PR. You can report an issue, and you can create a PR, which is just abbreviation of pull request to any issue, to propose your changes. Now, another very important aspect of GitHub is branch, right? So just imagine like it's a 4-lane road, and in every road the construction work is going on, and at the end of the day it's going to be merged in highway. So that's what branch is for. Like every person for every feature will create a different branch, and at the end of the day everything will be merged in the production branch, the master branch. So there are a few steps to install GitHub and get started with GitHub. So the first thing is you have to sign up for GitHub. That's the in the website, github.com. You have to choose a username which is going to stay with you like forever, and an email and a password. password, right? I already have GitHub account, so I'll just go on and log in to my system. Okay, this is what GitHub looks like. This is my profile. It gives you a profile view, and you can edit your profile info over here. Then it lists down the repositories and projects and packages, and basically you can see everything that you have in this screen. So next you have to do is you have to install Git in your system. Okay, so you created an account in your server, GitHub server. So now the next thing is how your local system will know that which now in the local system you have to install Git, like communicate with the server will install another package Git, which will be able to communicate to the GitHub server like github.com uh, directly from the CLI. Okay, so I have added the installation link in the slides itself. So just click on the images according to your operating system, and you will find the link to install GitHub. And so if as you guys have already started contributing to SCI, so I believe that you guys have already done this step before, but just to have a quick thing. So next we have to set up the username. So you create an account, but how you will know which is your account, which know to which account in server to send the things to. So there, so for that we config the username and user email in Git, and I'm not sure if you guys can see this. Let me exit and so it's basically git config minus global user.name and user.email. Okay. So now a little more technical thing. So there are two very important concepts in GitHub. One is origin or remote, and another is upstream. A lot of people get confused over here. So now the project admins and student coding, they have their own role, right? So when a person creates a repository, that becomes the remote of that person. Okay, so if the project admins have created their repo, that is their remote repo. So when we're gonna use their repo, we will have to fork it. Okay, so we'll have to fork it and we'll have to create our own version of that repo. So when we fork the same repo, it creates a replica of the repo in your own account. Okay, this will be in your project admin's account, and this will be in your own account with or your own username. I'll show how to do it in a few seconds. Sorry, few minutes. So the project admin's repo is the remote repo for the project admin, not you. So when you fork the repo, you create your remote. That's like a personal repo. Okay. So and then when you clone it to your local computer, so the remote repo becomes your origin, and the project admin repo becomes your upstream. Okay, so you will always have to push the changes to your origin and pull the changes from upstream. Okay, this timeline goes like this. Okay, so you fork the repo from somebody else's remote, you create your own forked remote repo, you clone it to your local system. When you clone it to your local system, your remote repo becomes your origin. Okay, so your remote repo becomes your origin, and the project admin's repo becomes your upstream. So when you push your changes, you push it to your origin, and you then when you pull the like update the repo, you pull it from your upstream. Okay. Next, some basic commands that we use in Git. The first thing is git init. So this command initialize Git in a particular folder, and like when you use git init in a folder, you'll see a .git folder in which all the setups will be there. Okay. Now git clone. What git clone does is it takes the repository from the server and creates a local, like, replica file in your local system. The same of the same repository, it creates a replica file in your own system. Then when you make changes to the code base, you use git add to add, like when you like shift to a new house, what you gather around the products and then you pack everything together and you send it. So git add gathers around the products, and then git commit sends packs everything up, and git push just sends them over into the server, right? So meanwhile, we use some status checking commands in it, like git status, so it says which files are added, which files are not added. So we'll also see that in demo in a few minutes. Now then, you are not the only person who will be working on master, right? If you are contributing to somebody else's code, somebody like a third person must be contributing as well. So how will you pull their changes, to pull their changes into your local system? We use git pull. And as I explained it before, like git branch. So it is used to create different branches, and branches for different features, and delete branches and so on, with different options. Now the last thing is git merge. So usually, like I prefer to do it over GitHub UI, but you can do it to merge a PR, you can do it in GitHub terminal or command prompt or git bash, whatever you're using in that as well. Okay. So next thing is contributing to GitHub. So there are two ways in which you can contribute. Basically, you can either create your own repo, or you can contribute to others' repo, right? So in when you create your own repo, there are two ways in which you do it. Like you create a local repository and you then send to the server, and to create a repository, or you create a local repository and you send, or you create a repository in GitHub and then you clone it to your own system, right? I'll just quickly show you how exactly to do it, and some basic things that involves things. So okay, so this is the folder in which we are going to work for another like half an hour or 45 minutes. So I'll quickly create a like local repo, will add it to our GitHub. So now you see, when I say, okay, when I see there is nothing inside the repo, right? I'm using a Fedora system, so I'll be using a lot of Linux commands. So ls is to list all the directories. So you can see there is nothing, even almost no hidden files in the system. So what I'll do is I'll do git init. Okay. Now you see it created another directory over in here named .git, which has different git configuration, the branches, the config description, heads, etc. So this is your local hidden git folder. Okay. So now, as I explained about remote and your upstream, so if you do git remote -v, you can see like if into which account git is linked to which repo git is linked to. So as you can see now, we don't have anything over here. Okay, so what we have to do is we have to go back to our GitHub, and we have to create a new repo here. Okay, so basically, it's a form to create the local repository. If the local repository name is available, it will show in green. Otherwise, we'll have to change the repository name. Then you can add the description. You can make it public or private. I believe most of you are students, so there is a thing GitHub does a student developers package, so you can have access to private accounts for free here. Okay, so we are gonna keep it public, and there is a option to initialize the repository with a readme. So this is very important. I mean, it's always recommended to add a readme file in your create a repository. So readme file is basically the blueprint of your project, like what is your project about, how your project is configured, how another person can install it, how a person should contribute to it. So a lot of things are there in the readme thing. And then you can add a git ignore directory. So what it does is, if you have a null modules or packages that you don't want to show in GitHub, or packages which can be installed by other person, but it's not necessary to push it to GitHub, you can add it to .git ignore files. And of course you can use license. So we won't get into that because that it's another complete another basics. Okay, so here we will create the repository. Now you see there is a URL. So this is the URL of your origin file, because like I create one file, so that's why it's I don't have an upstream right now. Okay, so this is my origin, and I have to add this origin to my local system. So we'll go back to our terminal, and we'll add okay, the command is git remote add origin and the URL. Okay, so don't get bothered if you can't remember the commands. That happens automatically when you do it multiple times. Okay, so now you see we have our origin added. Okay, it's written that this is your origin. From this repo, GitHub, like your Git CLI is going to fetch the changes, and to this only it's going to push the changes. Okay, now if I can simply add the like files inside this uh, project, and I can do whatever I want with this. Okay, so the next thing is, when you create a repo in your system, your server first, and then you try to put it in try to bring it to your local system. Okay, so the thing is, you just have to create the repo in the same way. Okay, this is like server repo, and the same things, initialization. And all you have to do is, so once the thing is created, you have to clone this. So the simple command is git clone. That means like clone whatever is in server to my local system. Basically, uh, now as we cloned everything from GitHub server, now you will see that the remote origin will already be added over here, because because it's pulled from the same Git. So our local system will already know like from which it is pulled. So, and to what it should be, the changes should be pushed. Excuse me. Okay. Okay, sorry, I cloned it inside the local repo. Okay, my bad. So, okay, we have to go back and we have to do it again. So, cloning inside the repo which you are running the thing. So now we can see there are two things here, and we have that are already originated to this project. So then now you can push and pull directly to the server. Okay, now this was like very pretty introductory thing that I believe everybody already knows. The most important thing that we should know is how to contribute to others repo, right? So a lot of people follow the same procedure that we used for the second time, like to create a repository upstream GitHub and like load directly in like the third scenario as well. But you should never do that. When you contribute to other people repo, you should always fork the repo. So to save the time, which we are already not doing, I have already created a repo inside student code in organization. So you can see this is my this is a repo which is created by the let's say organizers. Okay, so I want this thing to in my I want to contribute to this thing. Like you can see if it's like demo by it doesn't have a name and I want to change it. So let's see how to do it. So what I'll do is I won't go here and clone the repo. First what I have to do is I have to fork the repo. Okay, so what this thing will do is it will create a replica of the like owner's repo in my system. You see, previously it was in student code in slash GitHub webinar. Now it's in my own GitHub profile, and it says like forked from this, right? So whenever you contribute to any other person's repository, you should always fork it. And we can so the student code in repo was our upstream, and this is our origin. Okay, this is our remote. So now we will clone the repo. Okay, so now we have got this project in our like this project setup. So let's see what see. Okay, for some reason, okay, so as we forked it, so we have to add our origin and upstream manually to this system so that it knows that what is the upstream and what is the origin, right? So we will do git remote add origin this. Okay, so it now it knows that it has an origin which is like to where it should be pushed and where from where it should be fetched. Now we also have to add our upstream so we can keep track what is happening in the owner repo, and we can propose changes to that. So we'll also add stream over here. So let's copy the URL uh, from the upstream repo. Now you see, um, we have our both origin and upstream added over here. So okay, so now what you will do is you will whatever changes you make to this origins master, you have to propose that changes to your upstream. You never push the thing directly to your upstream. You have to push it in origin, then you have to propose the change into upstream, which will get merged to the upstream's master eventually. Okay, so the next thing is git branch. Okay. Um, okay. So you see, when you make changes in a development repo, so there will be one branch for like one feature. So you have your master branch. So no use uh, so when people get started, they push everything into master, and then imagine that you are in a company and you are like pushing everything to master, and somebody like some person, everybody is pushing to master, and somebody wrote some chunk of code which are broke. Okay, so that's a very bad way to handle a project, because you should never make any new feature in master branch. You should never push it to master branch. So this is the master, like the master branch is like perfect. Okay, it should be perfect. It should it shouldn't break at any point of time, and it should have tested features, right? So this is the master branch, and then another development branch, right? For example, so development branch keeps track of every other, like, the features, and keeps testing. So uh, so when you contribute to GitHub, for like, if you are assigned to a feature or bug fixes, you should always create like a different branch, and you should do your changes, and after you do your changes, it will be gradually merged to master by the project owner. Okay, so the basic thing is never push to master, always create a different branch, and do stuff in that, do your changes in that. So here are some basic Git commands. So Git branch lists all the branch names, and when you do Git branch, it only lists the branch which are your local. But when you do Git branch minus a, it will also like list down all the branches which are in your origin, in your remote. Okay, so if somebody else created a branch, that will also be visible in your git branch minus a. Then if you give git branch name, then you create a new branch, and so on. So there are like couple list of commands which you can go through. Okay, so let's see how. So right now, if I'll go into our GitHub webinar, so inside this folder in which we are going to do stuff, you can see I'm currently in master. Okay, so this is my master branch, and if you do git branch, you can see whatever is present there, and see, master branch is my local branch. When I did git branch minus a, I can see the branches in origin. Like remote as well. I have a master branch and a head, right? So by remote, I mean over here. Sorry, yeah, this one. See, so the remote master is this master. So the master we are in our local system is the green one. Okay, so if somebody else created a branch in your server which is not in your local system, it will be visible in red in remote as a remote branch. Okay. Then there are a couple of commands for inspection and comparison. I can show you git log. Git log shows all the commit histories, whatever you committed in this branch, everything will be visible over here. So whenever you start a GitHub project, it starts with the initial commit. When you create it, it starts with initial commit. Then you make changes and add different commits. It's like keeping a bookmark. Okay, I finished this much. Then now I finished this much. So it's like a milestone you add every time. Okay, so yeah. So another thing is git status. So git status shows us if there is any changes in the branch that we have to add to our server. Okay, so now I haven't changed anything here, but see, if I change, my laptop is freezing, so pardon me for that. So if I change anything here and you do git status, you see that is a modified file. Okay, so that's what git status is for. You can check your local changes to your files over here. Okay, now I'll go back to the changes so that we can. Okay, there are a bunch of other commands as well, like git log summary, reviews the changes, git log, or like one line, like it will say you the logs in one line. And if you make any changes, and you want to see in which line it made the changes, you can do git diff, so it previews the changes before merging. So for example, if I do it this over here, and I do git diff, so you can see it says me that in the readme file in line number between line number 1 to 8 is like I added this line. So in git def you can see in what files you have changed. So it's a very like useful command when to check if you by mistake did some changes to a file which you are not aware of. So this is a very cute command. Okay, so like there are three things that we do when we talk about making changes. Okay, so first thing is we make changes, whatever we have to do inside the repo we make the changes, then we add the changes with the command git add. So when you make changes like okay, so when you make changes it gets into the untracked local file. Okay, it becomes an untracked local file. Like your local system knows that this file is changed, but it's not being tracked in server, it's not being tracked in your commits. So what you do is you add the file to your uh, local with git add and it becomes staged. Okay, so it's like as I said, like you do git add, you like you continue fetching different things with git add, then you put it inside a trolley bag or whatever bag you have and you pack it, and that's what you do. Like that's what you do with git commit. You pack everything and you commit it to the remote, you push it you push it to the remote. So git add makes the untracked file into the staged file in the local system, and when you do git commit it gets committed to the remote. It says that okay, so this is the parcel that we have to send to server. Let's attach an id to this commit, let's give it a proper name, and let's see what it does. Let's give it an id and then let's push it to server. So that's what git commit does. It makes the changes ready to guess like send to server. Okay, so show you how to. So as I made changes here by Anisha. So if you see git status again, we have a unmodified file. It says that change is not staged for commit. It's not staged. It's not tracked, and this is the file which like it's just we changed, but we have no clue what this file is. So what we'll do is we'll add the that specific file here. Now when you do git status, you see it says it's like okay, now we know what which file got changed, and now we know that okay, we have to add this thing to our bag, and now we are all ready to like send everything away. So commit your changes. It asks to changes to be committed. So if you do git commit, okay, so so a few things to take care when you do git commit. So okay, so minus m is used to write the commit message in this particular line. Otherwise, it will take you to another screen. We can do that in the next commit, and always write the commit message properly. Okay, like I have written it in a very wrong way. I'm just writing it to keep track of commits. So for example, if I added Anisha, I should write adds name. Okay, you should always write what exactly you added the changes. Okay, what exactly the changes do, and it should always be in present or no present or present participle form. Sorry, present continuous form. Like it's adding or something, or it adds something. It should never be in the past form. Okay, so take keep the thing in mind. So you can do this. This will just create a commit like a message. It will just create a commit message with the changes in like in the system. For example, if I add this, you can see a commit got added, whatever file I changed, and then it will show in git log. So as we had seen before that first it was only an, but now we have a commit. So we can see that okay, now we have a commit. So we can do this. We can also do this. We can also do this. We can 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 do like our own commit here, like adds owner name. So you see, it shows different branch names over here, right? So it says that your origin master, the head of origin master, like remote branch, is updated till this commit. Okay, and the head of your local master is here in this commit ID. Okay, this is the commit ID, and it says the author name and the commit dates, in which date you committed the changes, right? So what we have to do is we have to push the changes to server. Like bagged, we know what is in our bag, we have to just send it to the aeroplane now. Okay, so this is done. Okay, so now let's make some more changes so that I can show you another way to commit the changes. Now I just added my surname in the file, and you see in git status again there is an unchecked file, and again we have to repeat the things that we did before. Okay, so this time I'm going to commit the message like in with a little more description. Okay, I will just add git commit. So, and when you do just git commit, okay, you will be redirected to another another, not page, but I'd say another screen. Okay, and you have to add your commit message over here, like adds sorry owner's surname. Okay, so this is the commit message. So when you're doing a very large changes, okay, so you can also add a description over here in commit. For example, this is the description. I can't think of any other description, so I'm adding this. But you can actually add like two, three lines of description after a commit message with a single line gap. So this will be your commit description. Okay, then you just go back and save it. Now if you will see the git log, you can see three commits, and this is the description of the third commit. Okay, so this is how you do the git commit, and you commit the changes to send it to server. Okay, okay, now sometimes we commit the changes, or we create do the changes in local system, and then we said, okay, we have to do some, we don't need these changes, we have to go back. So how to do it? So if your changes are in local system, that means if you haven't committed the changes, you just have added the changes, so you can do the first three steps, not steps, but there are three options to do it. You can use git stash. So I'll show you how to do it. So for example, I created another line here. Okay, git stash. Okay, so if you check in git status, it has a modified file, and what I did is I did git stash. Okay, so what it will do is it will remove the changes, and it will store in like it will store this thing in like a stash. It will store it in stash, and you can meanwhile you can go back to any different other branch or do your own changes. And then when you need this particular changes back, you just need to do git stash pop, and you get back all your changes that you had stashed. So this is how git stash work. Then another thing is git checkout file. So what it will do is it will discard all the local changes file permanently, like in a particular file permanently. And if you do git reset hard, it will discard all the local changes from all the files permanently. So if you have one file, you can use git checkout, and if you have multiple files which you don't from which you don't need the changes, you can do git reset hard. Okay, now the thing is here the first three things are like commonly used. The second third thing are like little complicated, and you should avoid doing this. So like this scenario happens when you have already committed the changes and you want to revert back the ID. Okay, so what you do is you simply use git revert and commit id. So as I had showed you before, when you do git log, you see this commit, like a big hash commit message, and this is your commit id. If you want to get back to this like revert back this id, you simply do git revert commit id. So what it will do is it will simply change the introduced commit. And if you want to undo changes of a single file, you can use git commit, git checkout commit id, and the file name, the specific file name in which you want to do the changes. And if you want to undo a single file or directory, then but you don't want the changes to be deleted, you want it to be in unstaged state. Like no, you want it to stay in your git status. uh, like here you have to do git reset commit id file. So I'm not doing it right now because again, when we'll do git push and pull, it's gonna create issue. So that's why I'm not doing it. If you guys want, I can do it at the end of the session when we don't have to use it again, so that we can debug it. Okay. Now another thing is, when we work on a PR, so it doesn't happen like over the night. Okay, some people work on PR for like 3 days, 4 days, 1 month, 2 months, 4 months, and some in cases like people like me, we work on PRs for like 1 year or more. So meanwhile you keep pushing changes to your pull request, right? You keep pushing the changes to server, you keep pushing different and different commits. So usually when you make a you ask for a review when the pull request is completely ready to when the feature is completely ready to be merged, you should all the last commit should always squash the commits. So what it will do is, for example, this white is your master branch and this blue is your own feature branch in which you are committing the changes. Like we okay, so like we did multiple commits, like 3 commits over here. And so what we'll do is, before the like pushing it to, like if you have multiple commits, before pushing it to the server, you should squash the commits into one commit. So if you have 3 commits, you should squash them and then you should push it to the server. You can do it with a simple command, git rebase minus I head and tilde n. So n is the number of commits you want to squash. If you have 3 commits, then you can replace 3 in place of n. And if you have 2 commits, you can replace 2 in the place of n. So let's see how we can squash the commits. Okay, so this is the log. I have to squash these 2 commits into one. Okay, so what I'll do is I'll do git rebase minus I had tilde. So I have 2 commits, so I'll squash those 2 commits. Okay, so it won't happen because we have unstaged changes, because we have a file that is not tracked. So let's remove it because we don't want that. Now let's try it again. Okay. So it won't happen till the commit branch is free. Now you see that there are nothing to commit, so we should be able to do rebase. Now see, it will like list down 2 commit messages over here to the 2 commit messages that we want to squash. I mean, we want to merge, right? So you have to write. This is a pick. This is pick. Okay. So what I'll do is I'll edit this pick and put an S here. So what it will do, it will squash the first commit into the second commit. Okay, so if you have 4 5 6 commits, you should like write s in front of every commit that you want to squash, and you should put the last commit or whatever commit you want to get it merged into as pick. So there will be multiple squash and a single pick. Okay, so you can write p or pick in you can write squash or s. There are commands that are written over here. You can but mostly we use only pick and squash. So you change the pick to squash and you save the file. Okay. Okay, something happened. Now, if any issue like this happens, you can simply abort whatever rebasing that you are doing. Okay, and you can redo it again. Okay. Sorry, there is a simple thing I missed here. Okay, so you should the first the you can't squash the first commit when like there isn't a previous commit over here, right? Okay, so I mean the second message will be squashed to the first message. The first message can't be squashed to the second one. So we did a mistake there. We have to add the squash to the second one and the below one. So you can't squash the first message. If you want to squash a message, then another message should be above it, right? So that's why it was throwing error. Now, if we solve, it will ask us to add a commit message. So because there are two commit messages, it will ask what commit message you want to commit because it will show a single commit message. So either you can keep any one of these two. You see, these lines are these lines are not uh, these lines are commented, so you have to choose from this line or this line, or you can simply remove these lines and you can add your own commit. So we'll add our own commit like okay. I'll simply going to add commit by Anisha. Okay, and I'm gonna save this file. Okay, now if you go to see the git log, there are again only two commits. Before there were three, now there are two commits. So now the commit is by Anisha and the initial commit which is all together. Excuse me. Now just imagine a scenario. Okay, so we are working on this project in in our this project, and for example, now I was working on master. Now I'll just I'll create another branch. For example, branch. I have to push the changes. Okay, the checkout. I'll create another branch, like feature, another feature branch, and I'll go over there. Before going to the feature branch, let's commit the changes that we did in the master branch, and let's push it to. I'll explain the push and other things later. So that now I just changed the I just sent the changes to the server. I will do that later. Now, yeah. So where we were, I created another branch named. I have to create another branch named feature branch. Okay. Now there is another branch called feature, and it shows that we are in master. There is a star in front of master. So we'll go to our feature branch. So now create your branch, and you see whatever changes was there in master, it is reflected in future branch. All right. So when you create a new branch, like if you are in branch X and you create a branch Y, whatever changes is in branch X will be reflected in Y. Okay. So you should, if you want to create a fresh branch, you should always go back to master and create a new branch. When you want to change a branch, you should always go back to master and change branch. Otherwise, the changes from another branch will be reflected in your branch, and it's just a lot of chaos. So always change to another branch from master. Go back to master, check out to master, and then check out to other branch. Okay. So now the thing is, okay. So let's make some changes here as well. So this will add a feature. We'll add a feature text here just because this is a feature branch. We'll add a text here, and we will commit the changes. Okay. Here we see that again the README file is modified, and we have to and commit touches. Let me just grab the commit message from before. Otherwise, I would have to type get commit minus m. I'll say commit by Anisha in teacher. Okay, I'm writing these messages because to show you guys the commit messages in UI. Do not follow this messaging this kind of message. Always write down what you have changed, right? So do not write like added readme or added this file. So don't follow my steps over here. So okay, I committed the changes. Now what we do is before pushing to pushing changes to a repository. So see this system. Okay. So uh, this is your, for example, this is your project admin's repo. Okay, this is your upstream. Okay, now this is your remote repository, your origin. Okay, this is your forked repository. So you never know, maybe some people are working on the master of your this project. Okay, so when for example you forked the repo on Monday, and you are doing your changes till Friday, and in between Thursday or Tuesday some people made changes to your this master, so this master changed. Okay, so what you always do is before pushing the changes to your origin repository, your origin repository over here, remote repository over here, you always pull the changes from your origin and your upstream. Okay, you should always update your upstream, right? So what it will do is, for example, you are so this is a commit A and commit B. For example, the circles are commits. Okay, so you commit the circles are commits. So the master had commit message A and commit message B, and then then you created another branch. Okay, you created another orange branch, and you did your changes D and E. Okay, so when you were doing changes to D and E, that is another green branch, another person who created a green branch, and he created master. Okay, he created a PR, his PR got merged, and now master branch changed. Okay, you don't have this change in your local system. So what you will do is you will pull the changes from master over here. Okay, you'll change the you'll fetch the changes from the master to your local branch. Okay, so what it does is you use git pull upstream master. So what it will do is whatever is in the master branch of your upstream, it will fetch the changes to your origin master. Okay, so whatever is in your upstream master will fetch to your origin master. If you do git pull origin master, whatever is in your origin master, it's fetched to your local system. Local, I mean master. Okay, so you see there are three systems. One is your upstream, one is your remote, one is your local. So you pull upstream, the upstream will send changes to your remote. when you pull up origin, the no changes in your remote master will be fetched to your local master. Okay, so all these updating things will happen in your master branch. It should always happen in your master branch, right? So this changes happen in your master branch. For you see this your this particular this first row. Okay, so when you fetched from up, this is your, for example, this is your origin. Okay, your upstream is somewhere here. So from upstream you pull changes to your origin, and from origin you updated your master branch. Yeah, so I'll show it to you better. Okay, so I'm in the feature branch and I have no clue like what happened in master. Maybe somebody pushed in master and somebody changed the master. Okay, so what usually I'll do is I'll go back to my master. Okay, so now I'll pull my origin. Okay, I'll pull my origin master to update my master branch. Your master branch should always be updated with your default repo, and your default repo should always be updated with your upstream master. So I'll pull my origin master. No, and it says that it's already up to date. That's because we haven't pushed any changes to our own repo, right? Whenever we push changes to our own master branch, we can pull, like, until and unless somebody else's push to your origin master origin branch, right? So possibility is somebody changed your upstream, somebody changed your project admin's master branch, some PR got merged which you don't have any clue in your local system. So in that case what you will do is you won't pull the origin, you will pull the upstream. Okay, okay, just a second. It says that upstream doesn't appear to be a Git repository. So let's check if we have the upstream over here. So okay, you see somehow I'm not sure how what I did. So it doesn't have an upstream here. So we have to add an upstream here so that it knows that from which branch we forked it, right? So you see now the GitHub webinar.git is in my account in Anisha1234. We have to add the student code in upstream here, right? So let's go back to GitHub and see the URL. Okay, so this is the upstream URL in student code, and we're just going to add it as we had previously added git remote add upstream. Okay, now if you'll do git remote v, you can see upstream. Okay, if there's any kind of changes in upstream, now that changes will be pulled here. Okay, it says that there are no commits here because okay, just a second. Okay, you see, all these changes that we pushed it to our origin. It has nothing with the upstream. Okay, so whatever changes you push, you should always push it to your origin. So uh, this is our upstream branch. Okay, student code and GitHub webinar. Now we have our own repository in our profile, right? So that is our origin branch. So you can see the commit message that we did is here. Okay, the commit message is here. So now now what we will do now, see, because there is no no commit message. There wasn't any commit message in our upstream branch. That's why it said that everything already up to dated. Okay, everything is already updated. Now just imagine somebody else is working on the upstream master. Somebody else committed changes to your upstream master, and let's see then what happens. Okay, so I'll request my the team people, somebody to commit changes in our this upstream.
Okay, Lakshya,
Okay, Lakshya, can you
Yeah, yeah.
commit the
Just give me a
changes?
minute.
Yeah. Okay. So what he is going to do is okay. So we both just imagine we both are working. Laksha and me are working on this particular project. I am working on my feature branch, and Laksha, I don't know what Laksha is doing, and he is creating his own changes and committing changes to like master. Okay. So let's wait and see what happens when the master upstream master changes. Okay. So what we did is we changed this feature thing in feature branch, and we have to commit the changes to origin. We have to commit the changes, but before that we want to make sure that our node base
Uh,
is
can you please recheck it?
updated. Okay, now you see Laksha committed a change in your upstream. Okay, like for example, there are 5 people in your participant, and somebody's PR got merged, and you are still working on that same file, and that commit message is not in your local system. You see, in I don't have any idea what Laksha committed because in my master, okay, if you go to my master, you see there are only changes committed by Anisha. That like my local system doesn't have any idea what is there in upstream origin right now. So what we'll do is we'll pull the upstream. Okay, we'll pull the master of upstream. Okay, spelling mistake. Okay, you see, it changed. It now it fetched the changes. It was fetching changes, counting objects, compressing objects, and it fetched the changes. Now, if you'll go into you can okay. So what happened is I worked on the same file and Laksha worked on the same file, and he changed something different and I changed something different. So this scenario is called merge conflict. Okay. So what happens? Suppose one you created another feature branch and you are working here. In the meanwhile, somebody changed the master. Okay, in the same file. So then it goes on to merge conflict because you guys change the same file and Git doesn't have any idea of which changes to keep, right? So there it shows the merge conflict. So the merge conflict is a very it's a very you have to solve it very efficiently, because if any mistake happens things can get worse, because sometimes while resolving merge conflict we tend to remove other people's changes, and or we we by mistake we fetch other people's commit to our PR. So make sure you do it in a proper steps. So to change the merge conflict, you have to go back to your file. I'm using VS Code here. So if you're using VS Code, you can see this thing. There will be, this is a current change. This is the current change in my branch. Okay. This is the change that is in my master, right? This is the change in my master, and this is the change that is the incoming change. This is the change that I pulled from Laksha, and I don't like, I have to decide which changes to keep. I should change my change, I should keep my changes, or I should keep Laksha's changes. So I can accept both the changes, I can accept only incoming changes, or I can accept only current changes that I did. Okay, so I'm going to keep my current changes. Okay, that is like this. Now what you have to do, you have to save the file. After you choose the changes that you want to keep, you have to save the file. Now you see this file get is modified, right? So you have to add this file again. Now if you do git log, okay, so I what I did is I okay, let's keep both the changes and see what happens. Okay, so I kept both the changes and I added the readme file. Okay, now I will commit these changes. Commit to by Anisha. Okay, now I'll again push the changes to master. Okay, so now there is another branch that we have is feature. Okay, we- now the feature branch doesn't have any idea what happened to master. Okay, and we have an unpushed changes here. We have like a commit message that we haven't pushed to uh, this our master yet. You see, in our master branch, we created another commit. Okay, but that commit message is not visible here, right? We can't see the commit message here. So we have to make sure that everything that is in upstream master or origin master should be in our branch before we push it to our server to create a pull request. Okay, so first thing that we did is we whatever was in master branch, whatever is when was in upstream master, we like fetch the changes to our origin master. Okay, now our origin master is up to date with upstream, but now the feature branch we have to like update the feature branch to our origin to our master branch, right? Feature branch is not up to date. You can see the second log message, like second commit by Anisha, is not visible here. So in this case what we'll do is we will rebase the branch on master. So what it will do is whatever commit messages you have done in this particular branch, it will put that message on top of the changes of master. If your branch is not up to date, it will up to date the branch with your master. Okay, now you see, which in feature branch we had changed the same file. Because the same file was changed, we are again getting into merge conflict. So to resolve it, like I had said before, to resolve it, you have to do whatever changes you want to keep, you have to keep. Now you see okay, now you see whatever when we are doing rebasing, so we made the changes. Okay, but still git doesn't know what we changed. Okay, it's not commit, it's not added, it's not staged. So it's saying that there is no branch, and it's still this rebasing feature means rebase is in progress. It's still getting rebased. So what we will do is whatever changes we added like to resolve the merge conflict, we will add that file. Okay, we will add that file. So you see, the changes was there in readme, and it's saying that rebase is in progress. Okay, and all conflict fixed is if all conflicts are fixed, then run git rebase continue. Okay, if we'll do git rebase continue, it will take the changes that you made and it will keep rebasing it. Okay, now you see the commit message got applied. Okay, if we'll see git log now, we can see our second commit as well. There is commit by Anisha, there is commit by Lakshya, there is commit by second commit by Anisha, and the commit in feature branch as well. So this is how you rebase a branch on top of master. Okay, to uh, to update the branch. Okay. Oh, okay. Sorry for all the screen thing, a lot of screen sharing, so issues. Now, as I have already shown you multiple times while doing it, you should always push your changes to your origin in your particular branch. Okay, you shouldn't push the changes to your master origin. You shouldn't push the changes to any master. Okay, in typical way. If you are doing your own project, then it's okay to change to your master. But when you are working with bunch of people, never push changes to master. Okay, master should always be perfect. The changes should be reviewed and then only added to master. Okay, so your origin master should always be up to date with the upstream master, and no changes should be pushed directly to your, neither to your upstream master nor to your origin master. Always push changes to your separate feature branch. Okay, so there are a couple of options when you do push. So you can push a branch to your remote repository. You can push so there are a couple of things that you can go through. So basically, usual case, we do just git push origin branch name. Okay, so we push to the origin, we never push to upstream, right? So if you want to push to the origin and you want to delete the branch, you do git push origin minus minus delete and branch name. So it will push the changes but delete the branch, right? So this is how you push the changes to your origin. So let me do it here in the feature branch. I'll just git push origin, what is the name, feature. Okay, so I'm pushing to my origin but not to my master branch. I'm pushing to my feature branch. Okay. Okay, so now you should be see all these changes here. Okay, so now see in the master branch, Lakshya committed in master branch and I committed a message 2 in master branch. Then there is a feature branch which has another commit, which is this feature. Okay, this is the feature that I committed for it. This is the feature. So this is in my feature branch. This is in my master. So you can see it here in the GitHub UI. Okay. Now the thing is, for example, you pushed your changes, and somebody also made changes to your master, as I explained before. Like you can use git pull origin master. You can pull the master, and not only master, with git pull you can also pull like changes of other branches. Like if you want to see what like feature person 2 is working on feature 2, so you can just pull the branch, that particular branch, and you can see what's happening there, and you can make changes there. So you can push the changes to update the server project, and you can pull the changes to update your local project. Okay, so now the most important thing is pull request. Okay, so this is you can see this is the master branch, right? So you created a feature branch, like we just created, we committed message, we committed, and then we rebased our particular branch. Like from master we rebased it. So now, like for example, like now you feel like, okay, my changes are ready to be reviewed by my mentors or my project admins. So what you will do is if you go back here, okay, to your forked repo, okay, you see it when you push changes to any other branch, okay, it says it will show a hint for you, like it's saying that feature branch has recent push. Okay, it is something that master doesn't have. So if you want, you can compare and create a pull request, right? So here you can create a pull request, and it says no, create a pull request by comparing changes across two branches. So you have to select here from what you have to push changes to what. So what I'm doing is, that my change is in my Anisha GitHub webinar, right, in feature branch, and I'm making a pull request to student code in GitHub webinar to master. So you see, I can create this pull request to Anisha one as well. I can make the pull request to other people's branch who forked the repo as well. Okay, so you can mention here to what repository you want to fork, and you can also mention to what branch. For example, like if you don't want the PR to be in master branch of upstream, you want to track it in some other branch, so you can create, like if there is another branch, like for example, like no development branch in your upstream repo, so you can also create the pull request to the development branch instead of master branch. Okay, so you can make the changes here in this particular form like thing. Now when you create a pull request, always mention which issue it's getting fixed. Okay, so you should always write fixes hashtag. So okay, so if you will use at the rate, it will show the people who are contributed to the repo, and you can add their name. And if you want to, you should always write down, mention which issue the feature is addressing to. For example, if I'll create, it's not showing because it doesn't have an issue. So let's see how we can create an issue. So I'll just tell how to create the issue in a proper way. So this is the issue page. You can create a new issue to create an issue for others. So it's like I'm giving the name demo issue, and I'll say that okay, uh, no, there is a template that must be shared with you guys to how to create issue and how to create PR. So you should always mention here, what is the issue and what is more description. And if it is a front end issue, it's always a good idea to add GIF images or JPG images or PNG images, whatever you have. So that gives the person who is solving a proper idea of what's happening. Okay, so this is markdown. You can see the review in the GitHub issue. You add this thing when you create issue. Now here there are assignees. You can assign any person to this issue whom you want to solve. So for example, I'm going to add a Laksha in this issue. So Laksha is going to solve this issue. Now there are labels which you can add. Like you can add what type of issue is this. Is it a bug? Is it a documentation change? Is it a duplicate issue if there is an issue already existing? If it's a good first issue, if a beginner can do it or not, if it's something we want help with. So you add changes, add labels here. So I added good first issue here. Okay, projects and milestones. So if this issue is a part of project, so that's another concept. Like when we do, when we release different versions, we track like a version 1 in a project, version 2 in another project. So that's another complete different aspect. So we won't get into that right now. So the project admins can create these things for you. If it's not there, that's okay. uh, so if there is any project that project admin has created, then you should add these things as well. Like if this issue is a part of documentation change, or if this issue is a part of some major changes that's happening with user or login or authentication. So you should do accordingly. Okay, now I'll submit the new issue. Now you see I have this issue already. Okay, now I will create this PR again. Okay, and I'll address the demo issue here. This is I'm creating the. Now see, as when I'm typing at the rate, you can see people who are contributor and whom you can tag. Okay, and when you type hash, it will show all the issues. So you should always mention which issue it's fixing. Okay, so it will get referenced automatically, and you should describe whatever changes you made, and you can create a pull request to input type. So GitHub recently introduced a feature you can directly create a pull request which is ready for review. But if you are currently working on this particular PR, this is work in progress, then you can create a draft pull request. Okay. So let me create a draft pull request. Okay. There, create a draft pull request. So what will happen is this pull request will be visible to everyone, but this pull request won't be able to get merged. It says like this pull request is still work in progress. You can't merge this pull request. Okay. So and once you are done with the review, you are done for the review. You want the review from your mentors or your project admins. You can just click on ready to for review. Okay. Now, when you do ready for review, the GitHub will check if this particular PR has any conflict with master. If the master changes again, if we somebody pushes some changes to master, you will see conflicts here. Okay, then you have to go back and pull the changes from upstream master and rebase the branch as we did. We solved merge conflict before. So once it is ready for review, you should add reviewers here, whoever assigned you the issue, whoever you want to review. So I'll request Laksha to review this PR. So it will show like Anisha has requested review from this person now. Okay, and if you have created a pull request, you should always assign yourself. You should assign like who is working on this pull request, and similar to the issue, you can mention here like. What kind of pull request it is. It is documentation change or no, it's a beginner friendly PR, or it's a bug, or whatever it is. You can add here. Now if you go back to the issue that we created, we reference the issue name here, right? So it will say that Anisha linked a pull request that will close the issue. Okay, a pull request is linked here. So check if this particular pull request solves this issue, and this issue will be closed by that PR. Okay, so this is a very interesting thing. You should always mention issue, because whoever will go through the issue, they will know that you have already solved it. Okay, otherwise a person won't be able to know if this issue is solved or not, right? So always follow this thing when you create a pull request. Okay, go back. Okay, so next thing is if somebody is requested for review, you can simply merge the request, or you see it's always a good idea to squash the commits and then merge. Like there are 3 commits in this branch. Okay, we forgot to squash the commits, so you should always squash the commit and send it. Or if it's not squashed, you can also squash and merge it from your own side. This merging thing is for the mentors and project admins. Okay, you can rebase it with master and merge. So you can do this thing here as well. But from a developer point of view, you are always recommended to rebase the thing with master and squash the commits, and then propose a pull request, then make a pull request ready for review. Okay, so they can simply click on this and merge the pull request to master. Okay, or whatever, whatever that person has requested. If a person has requested to merge master, it will click to master. If a person has requested to merge person has requested to merge it to development or any other branch, it will get merged to development or any other branch. Okay, so that's how pull requesting works. You can see the commit messages here, whatever changes that we did, we created changes, first change commit, then second commit, then commit in the feature, and it will show what all files are changed. Like when we started working on it, the file was like this, and then when we finish working on this, we will make changes like this in master. Okay, you can see the file changes over here. Now the people who will review the changes, like I have requested Laksha to review the changes, they can comment on this pull request, they can approve the pull request, or they can request changes as well. Okay, request changes in this particular line. So it's not visible for me because this is my own own PR. So if somebody else who has requested changes will see this, so these two options will be visible to them. Okay, so you can approve the changes, you can request changes, you can request changes in a particular line. Okay, so you can also tag a particular line and write down your review. Okay, you can write down, okay, change this line. Like if you are reviewing, then you can start a review on or your own PR. For example, if I do this, then it'll just, okay, I can't review my own PR. So you see that there was a box where it was written, it was the line was tagged and it was written change this file. So you can write down a review like that, and make sure to explain yourself when you ask for a review, so that the person who is doing the changes will be able to understand what you are asking for. Okay, now, okay, just a sec. Okay, now this is the very rare feature that get like very rarely used. I mean, I haven't used it like ever in like last 4 years. This is GitHub Git cherry pick. Okay, so what happens is cherry picking in GitHub means somebody is working on front end and somebody is working on back end, and some changes in front end is required to required in back end. Okay, so what will you do in that particular thing? Like like for example, master has A1, B1, C1 and D1. Now you are working on a feature branch and you need this particular D1 changes in your branch. You don't want A1, B1 or C1. You don't need these. You just need like D1 in here, in here, right? So what you'll do, you will do cherry pick. Okay, you can do cherry pick, and you can go to your feature branch and you can cherry pick the commit ID. Okay, this is the commit hash and commit ID. You can cherry pick this, and this particular changes will be appended in your branch. Okay, now I haven't done this I haven't done this. I haven't got chance to do this. But if you are playing around, you should definitely try this. This is a very important concept in Git, and this is used in like very high level projects. Usually you won't get to implement these things, but this particular thing, and there are like bunch of other options that you can use with cherry pick. So yeah, do play around with it. So you can it's just like an advanced version of git rebase, just that you rebase on all the commits. Here you will rebase on just one commit. Okay, so Laksha tells me that he has reviewed a PR, so let's see how it looks. Okay. Okay, you see, Lakshya has approved the PR. So when somebody will approve your PR, it will come like this, like, okay, this PR is approved. Now, when usually when if you have asked 3, 4 reviewers, when all the reviewers will accept approve your changes, then then somebody can merge this pull request to whatever branch you have applied it to master or to you know any branch. Okay, so yeah, this is how pull request and issues things work on GitHub. Now this is the most important slide, I will say. Okay, I see people like not following these, which is very you should GitHub open source is a place for collaboration and being epic, I'll say. So there are some etiquettes you should follow while doing contribution to GitHub. So you always fork the project you want to contribute to. You never push to upstream master, because if by mistake the person's master branch broke, that's gonna be a huge issue. Also, create pull request instead of directly pushing to master branch. Don't push to your origin master or don't push to your upstream master. Always create another branch and create a pull request. Okay, then the pull request review process will go on. You'll rebase and then way to do labels to issue and add the issue ID with hash. Okay, and another thing is, if there are multiple people are working on same project, then if a person is working on, like, suppose pull request 3, okay, and if you know that somebody is assigned with this pull request and already working, do not snatch that away. Okay, like, it's not gonna give you a plus mark, it's gonna add to your negative point. If somebody is already working on a pull request, wait for 15 days of inactivity. If the pull request is inactive for more than 15 days, then you add a comment that can I take it over. If the project admin or mentor says yes you can, or the participant themselves say that yes you can work on it, then only create changes. Never snatch away a pull request from someone. Okay, that creates a very bad impression, because that's how you cooperate. I mean, it's not a snatching competition. So be cooperative, be collaborative, and always create documentation. It's not only about how much code you changed, how many pull requests you made. These things also matter. How you collaborate, how you communicate to other people, like how you make the project better. Even if documentation is a huge part. So a lot of project, they might be very hi-fi, might have very hi-fi framework, but if they don't have proper documentation, then it's going to be very difficult to use the project in real scenario. So be creative with the documentation. So yeah, so as we say that, like, my code is open, and what about you? So it's always a good idea to keep your code open, and it inspires a lot of other people to get into collaborative programming too. So I'm looking forward to collaborate with you guys on GitHub. Okay, so that's it from my side. Thank you guys. It's been a wonderful session. Any questions on YouTube, just let me know, Laksha.
Yeah. So
And
that
don't
was
forget to
really an
follow
awesome
our
session.
webinars on Discord. You can ask us questions on LinkedIn, and we have our private GitHub profile link over here. So yeah, guys, see you over there. Any questions? Do let me know.
Uh, Thanks Anisha for giving an awesome help. Like it's really an interesting and some like it's really awesome because I am also using GitHub from last 2 years, but I also don't know some of these things you tell today. So it's a great start for some beginners. Okay.
Yeah, I really
Yeah, I
hope
really
so.
hope so. Yeah, like it's really you take it from start and you explain each and every point of Git. Like even I also don't know all of these, but I can say you are one of the experts in these. So hoping to see you everyone, like you all guys enjoying this webinar too. So we will come back with an amazing session soon. So be ready. Thanks everyone.
Thank you, everyone. Thanks, Laksha, for being such an amazing host. Thanks, everyone, to be an amazing audience. I'll see you guys over Slack or my social media profile. Okay. Yeah. Bye, guys. Take care.